Okay, let's look at example 1 in the textbook. This is on page 387. Okay, I encourage you to try to work through the question first before you take a look at it. Okay, so you pause the video now and try to work through this question. Okay, find the equation of the tangent 2. We've got x squared plus 1 as our function. We need to find the equation of the tangent. Okay, we're at the point where x equals 1. Okay, well, where is that point? F of x equals x squared plus 1. So we could determine where that point is by finding f of 1. And that point is the point 1, 2. Don't know if we need that information or not, but nice piece of information to have. Okay, the derivative is 2x. So to calculate the slope, to calculate the gradient of the tangent, we will find f dash of 1, which is 2. Okay, so therefore, gradient is 2 of the tangent line. Find the equation of the tangent line. All right, so we've got the point. Yes, we did need it. We've got this point of contact. We've got this slope. We can now determine the equation of the line. The slope is 2. The point b equals 0. Okay, so the y-intercept is 0. Therefore, the equation of the tangent is y equals 2x plus 0, better written as just y equals 2x. That's your solution. Example 2, find the equation of the normal to y equals 8 over the root of x at the point where x equals 4. Again, pause the video, practice this question on your own, and then see if you get it correct. So y equals 8 over the root of x. I'm going to write that as 8x to the power of negative 1/2. We could determine the point when x equals 4, y equals 8 over the root of 4, which is 8 over 2, which is 4. Therefore, the point of contact is 4, 4. Okay, the derivative. So using this information for my derivative, it would be negative 1/2 multiplied by 8x, and then decrease the exponent by 1, negative 3 over 2. Let's simplify that. Negative 4x, the power of negative 3 over 2, which is negative 4 over x cubed, which is square rooted. Okay, so when x equals 4, dy dx, slope of the tangent, equals negative 4 over square root of 4 cubed, negative 4 over, this would be 4 root 4, which is 4 times 2, which is 8, which is negative 1/2. Okay, so the slope is negative 1/2. Slope of the tangent. Slope of the tangent is negative 1/2. One way of writing that could be slope of the tangent is negative 1/2. Therefore, the slope of the normal is positive 2 over 1, positive 2, and we can determine the equation 2x plus b. The point was 4, 4, point of contact. So b is negative 4, which means the equation of the normal is y equals 2x subtract 4. Now in your textbook, you may notice that they've reported that as 2x minus y equals 4. Is that the same equation? Well, let's see. We could say y, add y to both sides, subtract 4 from both sides. Yes, it is the same equation. And example 3, find the equations of any horizontal tangents to this equation, y equals x cubed, subtract 12x plus 2. Again, pause the video, try to work this out yourself, see if you can do it. So here we have a cubic function, and we want to find horizontal tangents. So if we think about what a cubic function looks like, it's going to curve twice like this. Okay, so there should be two places where the tangent is horizontal. All right, find the equations of any horizontal tangent. So we have an idea what we need to do here. So dy dx, the slope at these points is going to be, the gradient at these points will be 0. Okay, so dy dx will be 3x squared subtract 12. We're looking for the place where the gradient is 0, so we set this equal to 0. I'm going to write it this way. I find it easier to look at. So factor out the 3x squared subtract 4. That is difference of squares, plus 2 minus 2 when we're factoring. So x equals plus or minus 2. Find the equations of any horizontal tangents. All right, so we're getting there. We know that at these 2 points, the x-coordinate is negative 2 and positive 2. Now we're going to need to know what the y-coordinate is. This is a horizontal line. The y-coordinates will tell us what the equation of those horizontal lines are. Okay, so in our function x cubed subtract 12x plus 2, when x is negative 2, y equals. Make sure you're substituting properly. That negative 2 is inside the brackets, so it results in a negative 8 when it's cubed. And that's 16. So therefore this is 16. The y coordinate is 16. And therefore the equation of that line is y equals 16. When x is 2, y equals 2 cubed, subtract 12 times 2 plus 2, so 8, subtract 24 plus 2, negative 14. So that's the y-coordinate of that point, telling us that the equation of that line is y equals negative 14. Oh, and I have a little error here, y equals 18. Hopefully you guys got it right when you did it. Let's go back and see where I went wrong. When I substituted in my 2, negative 8 plus 24 plus 2, must have just added wrong. This will be subtract 6. Yes, of course, that should be 18. And therefore y equals 18.